Okay, hello guys. So today I'll be talking about mole concept. Now, mole concept is a chapter that you can do, that you will be going through after you are good with balancing chemical equations, you are good with understanding your general equations, then you'll be moving on to this chapter. Okay, so now what this chapter is all about is it's supposed to tell us the correct quantities of chemicals to use. Okay, so for example, you are very good, by now you should be very good with balancing equations. Now you can tell me you can balance equations well on paper, right? But in real life, it is not just one block of magnesium to two blocks of hydrochloric acid. No, that's not the case. In real life, you are given a certain mass of magnesium and you are given a certain volume of hydrochloric acid. So if I have a certain mass of magnesium, how much acid do I need? That's what mole concept aims to tell us. Okay, so we will use mole concept to find out the answer. Okay. Now, as you can see, mole concept consists of mainly three different portions only. So first, we have the conversion. So what is conversion all about? All about conversion is basically just converting your real life units into your calculation units. So for example, we are given maybe 50 grams of magnesium. Okay, now we have to learn how to convert 50 grams into number of molecules so we can compare with our hydrochloric acid molecules, okay, which is stoichiometry. So after you are done converting, you will need to compare the units. Okay, so during comparison, that is called stoichiometry. Okay, so an example of stoichiometry we can see here. You can see Mg plus 2HCl, right? Yeah, so this itself is can be used as comparison already. So you can see that one molecule of magnesium, one atom of magnesium would react with two molecules of hydrochloric acid, right? So the ratio is 1 to 2. Yeah, so that is stoichiometry in a nutshell already. Then we have the last portion, which is called limiting reactant, which is basically the chemical that is insufficient, but we will go through that in further detail soon. Okay, so conversion is arguably the most important part of mole concept, because if you can't convert like your units in real life, like your mass, if you cannot convert into number of molecules, you basically cannot compare at all, then you cannot get your answer at all. Okay, so the first part of conversion formulas is to understand relative masses. So it is actually very simple. For relative atomic mass, which is a mass of an atom, okay, very simple, it's just the mass number of whatever you see on the periodic table of the element. So for example, magnesium you see here is 24. The mass number of magnesium is basically 24. Okay, very simple. Okay, next we have relative molecular mass. So relative atomic mass is a mass for atom, and then relative molecular mass will be mass of molecules. Very simple. Okay, so relative molecular mass, right, is just an addition of different mass numbers. For example, you see here magnesium chloride, right, MgCl2. So all you have to do is add 24 to 35 times 2, okay, because there is Cl2. So 24 plus 35.5 times 2, that gives you 95. So the molecular mass of MgCl will be 95. Okay. Okay, now to explain to you why relative molecular and atomic masses are very important is because they tell us the molar mass of the substance, okay, which is very important. Like for example, you see just now, right, we learned that the relative atomic mass of magnesium is 24, right? So the molar mass of magnesium will be 24 grams per mole. Okay, that's what molar mass is all about. It tells us the mass of 1 mole of a substance. And 1 mole is what we are going to use as a reference. Okay, it's like 1 kg. Okay, like 1000 units, like that. Okay, so 24 grams of magnesium is 1 mole. Okay, and then for example, we see above the relative molecular mass of magnesium chloride is 95, right? So the molar mass of magnesium chloride would be 95 grams per mole. So what that means is that 1 mole of magnesium chloride is 95 grams. And the unit of mole, right, is what we are going to use to compare molecules. Okay, so it's going to be like 1 unit of molecule like that. Okay. Okay, now to explain mole, the concept of mole, like what is mole better, I have decided to add this equation to show you what happens when sodium is added into water. So when you put sodium into water, you get sodium hydroxide and hydrogen gas, right? So what this mole is all about is, let me just add some few parts to show you. Now you can see that 2 molecules of sodium would add to 2 molecules of water, correct? So the ratio would be 1:1, like that, correct? Okay, so it's 1:1. So if I have 1 mole of sodium, I would require 1 mole of water, right? So this should be something you guys understand, because the ratio is 1:1. So if I have 1 mole of sodium, I will have 1 mole of water. And then if you look at the periodic table again, you will see that sodium has a mass number of 23. So if I have 1 mole of sodium, that would be 23 grams, right? Because the mass number of sodium is 23. So the molar mass of sodium will be 23 grams per mole. It's basically the same thing, okay? Mass number and molar mass will be the same thing, okay, for solids. Okay, and then if you look at water, water is H2O. So 2 plus 16, because H2, 1 times 2 gives you 2, plus 16, that gives you 18. So 18 grams per mole. So what this tells us is that if I were to have 23 grams of sodium, I'm going to have to require 18 grams of water. Okay, so basically mole is just a unit of comparison. Okay, it's like something that allows us to compare. Okay, you can take it as 1 molecule to 1 molecule, although it's not. Okay, 1 mole represents 6 times 10 to the power of 23 molecules, but it's just a unit that we compare. Okay, it's very simple. It's like 1 kg is 1000 grams, but we don't always say 1000 grams, we just use 1 kg, right? Same thing. Okay, so as explained and shown just before, 1 mole basically represents 6 times 10 to the power of 23 molecules of a certain substance, right? So if I have 95 grams of magnesium chloride, I would have 6 times 10 to the power of 23 molecules of magnesium chloride. Okay, now this would be the first formula for conversion of solids that I will be showing you guys. So number of mole of a substance is just the mass given divided by the molar mass of the chemical. So to better show you an example of how this formula will come into action is, for example, you see here. So we already know that magnesium has a molar mass of 24 grams, right? So 1 mole of magnesium would be 24 grams. So now I have a sample of 48 grams of magnesium. So how do I change this into number of mole? So if I already know that 1 mole is 24 grams, right? Okay, what about 48 grams? How many mole is that? Okay, I'm not sure, right? But I already know that 1 mole represents 24 grams. Okay, so in this case, what does that mean? It is 24 grams a mole, right? So all I have to do is use 48 to divide by 24. 48 gram divided by 24 grams per mole, and this will give me an answer of 2 moles, right? So if you look at the units that are shown above, it is basically mass over molar mass giving you a certain mole. Okay, so that's where we have our formula. Okay, number of moles equals to mass over molar mass. So that is our first equation. Now I need you to note that that is only one of 3 different equations that you guys need to know, because there are 3 states of matter, right? Obviously you are tested on 3 different states of matter. Okay, so there will be formula for 3 different states. So the one you learned just now is for solids, which is mass. The next one you'll be learning is concentration, which is for solutions, like for example your hydrochloric acid, your sodium hydroxide solutions, all those kind of things. Okay, and then the last one you have for gas. Okay, yeah. Okay, so for converting concentrations of solutions into number of moles, you have to first understand that concentration is mole per dm cube or gram per dm cube. So the first thing about solutions I need you to know is that questions are normally appearing in terms of like mole per dm cube or gram per dm cube or something per cm cube. Now you all need to understand that cm cube is basically just ml, okay, milliliters, and then dm cube is just liters. So if we were to do a conversion from dm cube to cm cube or cm cube to dm cube, you need to understand that 1000 cm cube is 1 dm cube, okay, just like 1000 milliliters is 1 liter. So an example of concentration they will give you is something like that, okay, and then they will give you a certain volume as well, okay, shown here. So now I have 500 cm cube of NaCl solution at a concentration of 58.5 grams per dm cube. Now let me explain to you all what this 58.5 gram per dm cube means first. Okay, what this means is that in this salt solution, right, where I put NaCl in water, every 1 liter of water there is 58.5 grams of NaCl, or rather every 1 liter of salt solution there is 58.5 grams NaCl, okay, so that's what it means. So if I were to find out what is the total amount of salt that I placed inside this beaker at 500 cm cube, what I first have to do is to convert this volume into dm cube, okay, so I have to convert this volume into dm cube. So 500 milliliters is basically 0.5 liters, right? So that will be half of this container here. So if 1 liter of salt solution contains 58.5 grams of salt, how much will 0.5 liters contain? Okay, now this one is very simple. Okay, all you have to do is just multiply by half, okay, which is 0.5. Okay, obviously we'll be expecting less salt here, right? So all you have to do is just use 0.5 dm cube to multiply by your concentration, 58.5 grams per dm cube. Okay, this will tell us the amount of salt that we have, which is 29.25 grams. Okay, so there is 29.25 grams of sodium chloride in 500 cm cube of water. Now this is not the end of it yet, because we have to convert the mass, grams, into number of moles. Okay, now how to convert grams into number of moles? That is basically using the formula that you have learned just now, which you will find out to be 0.5 moles. Okay, now this is quite difficult, I understand. There is actually a simpler variant, okay, there is another type of concentration that is much simpler, okay, as shown here. So 1 mole per dm cube Na solution, which is at 500 cm cube. So you'll see that the difference between this and the previous question is that the previous question consisted of gram per dm cube. Now you can see that the units are different. So for the top one, which is the easier one, you have mole per dm cube, and then for the bottom one you have gram per dm cube. Now why mole per dm cube is a lot simpler is because you only need one formula and you can get the mole concept. You can get the number of moles straight away. You can convert it in just one formula. Okay, you don't have to convert the mass into number of moles. You just multiply this by this and you immediately get number of mole. Okay, like that. Okay, 1 mole per dm cube multiplied by dm cube immediately gives you mole. Okay, you can do the unit dimensional assessment here. Okay, and it immediately gives you mole. Okay, whereas for the grams per dm cube, right, it's a bit different, because grams per dm cube you have to multiply by dm cube first, and this gives you gram. Okay, this gives you gram. After that you still have to use gram divided by grams per mole, which is the molar mass, to give you your answer. Okay, that is why grams per dm cube is slightly more troublesome than mole per dm cube, but I hope you get the idea. Okay, so our second formula is just like that. Okay, concentration multiplied by volume giving me number of moles. Okay, very simple. The previous formula I shown you was for mole per dm cube. This one is for gram per dm cube. Okay. Okay, now this is the last and pretty much the easiest one, because this is basically like your mass formula. Okay, so remember for our mass formula, right? So for our mass formula, you can see here, basically it is just using the mass given, okay, mass given divided by the molar mass, okay, which gives us our number of mole, as seen here, 2 moles of sodium, as you can see here, right? So the reason why volume is very simple is because this molar volume is fixed for every single type of gas out there. Okay, let me explain it to you. Okay, as you can see here, 1 mole of any gas at room temperature and pressure will have a molar volume of 24 dm cube, or 24 liters, or 24,000 milliliters. Okay, so the molar volume of any type of gas is 24. So if I were to have 48 dm cube or 48 liters of oxygen gas, how many moles is that? Basically, I just need to understand that 1 mole of any gas is 24 dm cube. Okay, then I work accordingly. Okay, so all I have to know is molar volume of oxygen gas is 24 dm cube per mole. So all I have to do is use 48 divided by 24 to give me 2. Okay, and my answer is 2. Okay, enough of oxygen. Let's take a look at fluorine gas. So now again I have 48 dm cube of fluorine gas. So what do I do this time? Again, I just have to know that the molar volume of fluorine gas is 24 dm cubes per mole. So all I have to do is again use 48 divided by 24, which gives me the exact same answer, 2 moles. So for gases, it's very simple. All you have to do is make sure that your sample is in dm cube, then you divide by 24 and you immediately get your mole. That's it. Okay, very simple. Okay, now I'm pretty sure you guys are in no position to learn any more things. So I have not gone through stoichiometry and limiting reactant with you guys. I've gone through the conversion formula, but trust me, this is the bulk of the entire chapter. In fact, these two portions only took up 2 pages of the entire set of notes. So I hope you guys understand, and I will show you a page of a summary right now. Okay, as shown here. So this is the basically a summary of what you will have learned today. Okay, the 3 formulas. I know it is quite difficult, but I just hope that you guys understand the logic behind this. Okay, the main goal of all these formulas you see here is to convert something that we can measure in real life into something we can calculate. Okay, so that's what conversion formula is all about. Okay, converting something in real life measurements into something we can calculate and compare. So to explain what do I mean by compare, now I'll just give you one last example to show you how all your formulas can be applied here. Okay, so I have 46 grams of sodium, as you can see here. Sodium will react with water to give me an alkali, sodium hydroxide, and hydrogen gas. So if I've got 46 grams of sodium, how much water do I need? Okay, so now let me show you. Okay, first step, we just have to convert our sodium into a measurement we can compare, which is number of moles. So as always in every single type of mole concept question, the first step would be to convert into number of moles. So I know that sodium has a molar mass of 23 because the mass number is 23. The number of moles would be 46 grams divided by 23, which gives me 2 moles of sodium, right? So I've got 2 moles of sodium atoms. After this, what I do is, because I have a unit where I can compare already, I immediately start comparing. So here is where your balancing chemical equation is very important, because it allows us to compare properly. Now where do I get these 2 numbers from? Here it's basically 2 sodium atoms and 2 molecules of water, as you can see here. That's why the ratio is 2:2, which can be simplified into 1:1. So if I have 2 moles of sodium here, how many moles of water do I need? Now this answer will be very obvious. It will be exactly the same, which is 2 moles, right? So the last step I need to do is just to convert these 2 moles back into mass for water, and that will be my answer already. And by the way, this step here is stoichiometry, so you can see how simple that is. All I have to do now is just find the molar mass of water, which is 18, and then I times 2 because 2 moles, and that gives me 36, and my answer will be 36 grams of water. Okay, so if I have 46 grams of sodium, I will need 36 grams of water. So you can see it's not a very simple kind of thing. It's actually very simple, but it's not just like use 46. Oh, so if I have 2 units, 46, I have 2 units here, 46. It's not that simple. It's not like that. You have to convert it into number of moles before you can compare it. Okay, so you can see every single type of mole concept question, or rather 90% is just converting into something you can calculate, comparing, and then converting back. That's it. It's just a 3-step process. Okay, so I know that today's chapter is quite hefty, okay, and we have not completed it yet, but mole concept is a very important chapter, and you cannot expect me to shorten it into a 3-minute video, okay? So yeah, I hope you learned something from this video, okay? I will post another video in the near future as a continuation of this, which I will cover stoichiometry and limiting reactant. Okay, I hope you understand what I'm talking so far. Okay.